Hello, this is the second video for section 9.8. So the inequalities we dealt with in the first video are quadratic inequalities, which means they can be represented by parabolas. And if you remember, a parabola is always can be thought of in three different ways. Either has two real solutions, one real solution, or zero real solutions. For this first case, we have two real solutions because it crosses the x-axis twice. And remember, you get two real solution when the discriminant is greater than 0. So when you have this, the x-axis is representing our number line. So when you have two real solutions, it splits the number line into three cases, which are like the first three examples we did. And thankfully, if you notice, either you get two pieces that match or one piece that match. So the only possible answers you can get is you can get, for example, a single interval with parentheses, so like a comma b, or a single interval with brackets, a comma b. Or you can get two intervals, so negative infinity to a union b to infinity, and then negative infinity to a bracket union bracket b infinity. And you'll see we did an example of type 1, type 2, and type 4. We didn't do an example of type 3, but it would be very similar to the type 4, just without an equal sign. Now in this case, we only have one real 0, so it splits our number line into two regions. And remember, we get one real 0 when the discriminant is equal to 0. Now in this case, you can get some weird looking answers a little bit. For example, you can get a single solution, so x equals a. So that's not an interval of numbers, it's one number. So in interval notation, you would do brace a brace. Or you can get all real numbers. And remember, all real numbers is negative infinity to infinity. It's also possible to get no solution here. And last, you can also get negative infinity to a union a to infinity. And then the last one is when it doesn't cross the x-axis at all. So this is when the discriminant is less than 0, and it doesn't split up the number line at all. In this case, you either get negative infinity to infinity, so all real numbers, or you get no solution. There's no other option when you have 0 roots. So example 2, solve the following inequalities. We have x squared minus 4x plus 4 is less than or equal to 0. So the first thing I'm going to do is find the roots. So I'm going to change it to an equal to sign. This is factorable as x minus 2 times x minus 2 is equal to 0, which means x minus 2 equals 0, which means x equals 2. So now when I do my number line, I only get a single point on it. So because I only have a single point, I need two test values. Let's do 0 and 4. So 0 squared minus 4 times 0 plus 4, which is equal to 4. Is that less than or equal to 0? False. And then 4 squared minus 4 times 4 plus 4. That is also equal to 4. Is that less than or equal to 0? That is false. So notice how both the intervals are false. So the only possible solution is at 2. So our answer would be x equals 2 if there's an equal to part here. Well, thankfully there is an equal to part there. So that is our answer. So remember, in interval notation, that would be brace to brace. But now let's say if there was no equal to sign here, it was just a less than symbol, then we couldn't equal to, so our solution would be no solution. So that's the difference between getting a single answer and no solution with a single root. And now part B. X squared plus 3x plus 3 is less than 0. So this is going to be x squared plus 3x plus 3 is equal to 0 to find the root, which it's not factorable. And because my middle term is not even, I'm not going to try to complete the square because I'll introduce fractions. Instead, I'll just go to the quadratic formula. So negative b plus or minus b squared minus 4 times a times c all over 2a, which is negative 3 plus or minus the square root of negative 3 over 2, which is negative 3 plus or minus I square root of 3 all over 2. So remember, our critical points are only the real zeros. So since this only has imaginary zeros, there are no critical points. So I do not split my number line at all. That's our number line. There is no critical points. But we still need a test point. So you can pick any number you want. I'm just going to choose 0. Plug 0 in. We get 0 squared plus 3 times 0 plus 3, which is equal to 3. Is that less than 0? So that's false, which is false. So that means our answer, because everywhere is false, is no solution. Now, if this happened to have been true, that's when we would have did negative infinity to infinity. And that's a good place to stop for the second video.